our goal is to finish these notes, which we should be able to finish. I just can't offer you the extra work time like I thought I was going to be able to. But yesterday, we talked about we introduced lesson 6.4. And on the front, if you recall, we looked at the logarithmic functions. We looked at how to graph them. And we talked about those 5 questions, right, that you're going to see in homework. The domain, the range, the intercepts, the asymptotes, and in behavior. Now, we started right at the end of class. I kind of said, hey, remember this chart? Yes? Been there, done that. We've seen this chart a lot. Now, with that in mind, we have some questions. I'm not having you graph these, and I don't think homework really has you graph them, but we have some questions. And so we talked about yesterday. I'm going to start here and review. But g of x equals log base 2 of x plus 3. What's that plus 3 doing here? That plus 3 is in the parentheses, right?
Yeah.
So in general, that's going to take my graph to the left. Now, here's the deal. That's not exactly what the question is asking, though. Okay, and I don't remember if they ask in general in the homework about what the graph does, but I know you'll see specific questions about, okay, how do the asymptote and x-intercept, how are they affected by this? So if I go back here and look at a couple of graphs from yesterday, here's what our graph was looking like. So if you missed yesterday, you have an idea of what our graph was looking like. If I take this graph and I move it left 3, is that asymptote going to have to scoot over left 3?
Mm-hmm. Yes.
And it is. So it's also translated left 3. So when you move that graph left or right, your asymptote's going to move with it. Is my x-intercept going to move? Yeah, if I'm taking this graph and moving it left 3, my x-intercept's going to move also. Okay? So with that in mind, you'll notice what I have here, and I think I kind of wrote this idea yesterday. In general, the graph translates left 3 units. Notice when my graph is moving left or right, your asymptote and x-intercept are also going to do the same. They're going to move that left or right however many units. Okay. I believe in your class we started talking about B. Because I remember we had a discussion, I think, about.
Didn't get done.
But yeah, we didn't. I don't think I fully wrote it down or anything. But what did we discuss here? Natural log of x plus 4.
X is outside of parentheses.
Okay. There are no parentheses there. If I put parentheses in, the only thing that goes in the parentheses is the x. Because there's, otherwise the parentheses would already have to be there. So that plus 4 is doing what to this graph?
Moving it right 4 or up 4.
Okay. It's an up or down 4, so it's going to be an up 4, the direction of the sign. So I'm going to write here, in general, the graph translates up 4 units. Okay? So in general, and again, I can't remember on Savas if you get asked, what does the graph do in general? But I know you get the specific questions of, okay, what does the asymptote do? And what does the x-intercept do? So, let me go back for a visual. If I use this graph as my example, and I take this graph and I move it up 4, what does this asymptote do? Is this vertical asymptote of the y-axis, is it going to move? No. My graph is just going to move up right beside it, isn't it? So is my asymptote going to be affected?
Nope.
No, it's not going to be affected. Now, if I take this graph up and move it up, is my x-intercept going to be affected?
Yep.
Yeah, because this point is going to move up 4, and whatever is 4 down below, so like this point, it's now going to be my x-intercept. So my x-intercept will change, won't it? Okay, so that's the information we need to look at here. So the graph translates up 4 units. Asymptote will not change. X-intercept will change. I'm struggling with remembering how they asked that in the homework. Is it just does it change or not? Or is there something more specific? And I don't remember. Okay. So I'm just going to say x-intercept will change. And I guess if I need to get more specific on that, we can talk about, I'll look at homework after this and talk about it, okay? I don't remember if I need to get more specific or not. Does that make sense?
Yeah.
Okay. And I guess if anything else, the x-intercept's going to be smaller, is what I can say. But we won't have an exact value, and I know they won't ask you an exact value. Okay. C. What is being done to this natural log graph? Okay, so we're multiplying by 5. Multiplying by a number out front is either a vertical stretch or compression. Because it's a number bigger than 1, we know graph is being vertically stretched by a factor of 5. So graph is vertically stretched by a factor of 5. And then the question becomes, start thinking about, does that affect the asymptote? And does that affect the x-intercept?
Mm-hmm.
So if I go back here and use a graph as an example, so vertical stretch. Do you remember what we've done in the past to deal with vertical stretch? What kind of values have we multiplied by 5?
Y value.
The y values have been multiplied by 5, yes? So if I multiply these y values by 5, it's going to take those y values and pull them up 5, or up by a factor of 5, or maybe down farther, right? With that in mind, is my asymptote going to change?
No.
No, because this graph isn't moving left or right. It's just kind of stretching. Okay? Is my x-intercept going to change?
Yeah.
Why?
Because no.
What's the y value of the x-intercept? 0. And what's 5 times 0 going to be?
0.
Still 0. So in this case, we're back to another one where neither asymptote nor intercept will change. Actually, no, wait. We haven't had one where neither change, right? I'm going to say neither asymptote or x-intercept will change. Probably should have just said asymptote and x-intercept will not change is what I should have said there. Okay, so you have to look at what is the transformation happening. Some of the transformations will cause the intercept and asymptote to change. Some of them will not. And hopefully I've given you some insight there. Okay? One last section. And that last section is talking about inverses. Now, back in Unit 5, we talked about inverses. And we talked about them yesterday also, right? How do we find an inverse of a function? Take the x and the y and we flip them, right? If it's a list of ordered pairs, we did this yesterday. We took the x values and the y values and we flipped them. If it's an equation, the first thing we're going to do is we're going to switch, or I use the word interchange, x and y. We're going to put x where y was, y where x was, and then we're going to solve for y. Now, the reason this is a little bit different this time, when we go to solve for y, this is going to, notice on my note here, it may require switching between exponential and log form. Or in other words, we may be doing some
Left, right, middle.
left, right, middle today. Okay?
Way up front.
So, as we look at A, find the inverse is what we're doing here. What do you know about f of x?
It's Y.
That is a fancy way for saying y, yes?
Yes.
Been there, done that. Now, step 1 says we take x and y and we switch them. So instead of saying y equals, this is going to read x equals. Instead of 10 to the x plus 1, it's going to be 10 to the y plus 1. Okay, so that step right there, from there to there, that was me switching x and y. I don't know if you need that side note in there or not, but that's what I did. I switched x and y. Now what's my job after that? Solve for y. Where's y?
In the exponent.
It's on the right. It's in the exponent. It's really difficult to solve for something in the exponent, which means we need to get it out of the exponent. How am I going to suggest we get this out of the exponent? This is where your left, right, middle is going to come into play. Now, when we say left, right, middle, that left, right, middle is based off of the assumption that the base is already on the left. So my exponent's either already on the left or my log's already on the left. So I'm going to take a moment and switch this around, as in just flip-flop I said. 10 to the y plus 1 is equal to the x. If I think left, right, middle, my base of 10 is my left. It's now going to be the base of my log. So this is going to be log base 10. And then my right and middle are going to flip-flop, right? Or correct? So if we think of this 10 being the left, y plus 1 is the middle, x is the right. So I'm going to flip-flop these. X is going to now become my middle, and y plus 1 is going to become my right. So my base of 10 stayed. The location of the other two pieces flipped. Are you okay with what we did there?
Sure.
Now, is it the answer? Well, have I solved for y?
No.
It's almost the answer. We're also very close. Yeah, how do you get y by itself? If it's y plus 1, we're subtracting 1. And so when I subtract 1, this is, I'm going to go ahead and reverse it. Y equals log base 10 of x minus 1.
Boom. Answer.
Okay. Am I done?
Yep. Yes.
Do I have y equals?
Yes.
Yeah. Now, you can write this one. You can write this one of two ways. In all honesty, I would guess Savas will already have the y equals part there for you. Or, since it's an inverse function, we could also write it with our inverse notation, if you recall. Now, it's base 10. Do I have to write that base 10? No. And in fact, that's something I could see Savas counting you wrong if you put a base 10 in there. I'm just saying. I don't know that for fact, but... So you could write this as y equals log of x minus 1, or, what was this, f? So f inverse of x equals log of x minus 1. I personally am happy with either of those. That's me. I can't speak for anybody else, right?
Right. If we put log base 10 on the test, are you talking about?
I will not. As I said, I can just see Savas being kind of annoying like that, you know.
Yeah.
Okay, B. Switching it up right off the bat on you. This time we're starting in log form. So just realize we're going to be going the other way eventually, but, okay, what do you know about g of x? It is the same as y. What do we do to find inverse? Switch x and y. And so instead of y equals, I'm going to say x equals. Log base 7, instead of x plus 5, I'm going to say y plus 5. Okay. I switched my location of x and y. My job is to solve for y. What's the problem with solving for y right now? It's in the parentheses inside that log. So this is where we're going to have to use a disagree. Left, right, middle.
Left, right, middle. Yeah.
Now, and again, the way these are lending themselves to be today, in order to use left, right, middle, if you're hung up on these specific locations, the log needs to move to the left. So if you need the better visual, flip-flop this around and think log base 7 of y plus 5 equals x. And then I'm looking at my left, right, middle, yes?
Yep.
7 is the left, y plus 5 is in the middle, x is my right. I want to reorder these in my exponential form. So exponential form, we're going to have my left of 7, so base of 7,
Exponent.
raised to the right of x is equal to y plus 5 from the middle.
Oh, then you minus 5, and it's y equals.
Then when you get to solving for y, that's the easy part today, right?
Yeah.
If it's y plus 5, subtract 5. And so I'm going to have y equals what?
7x minus 5.
Now make sure it's 7 to the x
No,
minus 5 is not in the not in the exponent. You could write your answer like this, or this one would be g inverse of x equals 7 to the x minus 5. So those are the two different directions you could end up going today, yes? Okay. Let's practice C and D real quick. Okay. They're kind of a repeat here. On C, what do we know about f of x?
it's equal to y.
Okay, that is y. So if this is y equals 3x to the 2, to find my inverse, we start off by switching. So instead of y equals, it's x equals. Instead of 3 to the x plus 2, 3 to the y plus 2. Now, if you can work from here and go straight out of exponential form to log form, that's awesome. If you still need that visual, then go for it. Okay, so if I reverse this and put my base on the left, 3 to the y plus 2 equals x. Notice I'm solving for y and it's in exponent form, right? So we have to get out of exponent form. The base of 3 is going to be the base of my log. So log base 3 of what equals what?
Of x.
Of x equals y plus 2. Because what's over here on the right switches to the middle. What's in the middle switches to the right. And can we easily solve for y at this point?
Yep.
Yeah. If it's y plus 2, you are subtracting 2.
Sure.
So options to write this. Y equals log base 3 of x minus 2. Or f inverse of x equals log base 3 of x minus 2. Do I need to write my base?
Landry Copeland, please report to the high school office. Landry Copeland, please report to the high school office.
Yes.
Yes, I need to write that base of 3, don't I? The only base you're not allowed to write in logs is base 10. Okay, obviously natural logs is the other one, but. Okay. One more. Did you guys get done already? You're waiting on me?
Oh, I got this.
Okay, that's good. G of x is the same as y. So to find your inverse, switch them. Instead of y equals, x equals. Instead of log base 7x, it's log base 7y minus 2. I'll be curious, those of you that worked ahead, did you catch what's going on here? Okay, we have the issue that the y is in the log again. We need to get out the log, yes? What'd you guys do at this point?
I switched, I moved my x to the other side. And then I did log base 7 to the x equals y minus 2.
Okay.
I just did that.
There's a slight issue here, though.
But what'd you do there, smarty pants?
Okay. Okay, here, guys. What's different about this problem versus the other log problem we did? Okay. This one, x plus 5, was in parentheses. That entire x plus 5 is part of the parentheses. This one, minus 2, is not in parentheses. So here's what I'm going to say. I can't do a left, right, middle right now until my log is by itself. Right now I have the log of x subtracting 2. So what I actually need to do first of all is isolate my log. So I can do a left, right, middle. You always want to isolate your exponent to do left, right, middle, or isolate your log. So first thing we're going to do is actually plus the 2 over, or add the 2 over. Now when I add my 2 over, I'm going to have log base 7 of y is equal to x plus 2. Now is my log by itself. Yes. And the only difference is the parentheses on the previous one, not parentheses on this one. That was your clue. Okay, that's what you have to watch for. Now I can do a left, right, middle. My base on the log is my base in the exponents, yes? And then basically switch the other two pieces, yes? So 7 to the x plus 2
Equals y.
equals y. So the left raised to the right equals the middle. And in this case, we're done?
Yep.
We're solved for y. So you can write this as y equals 7 to the x plus 2, or g inverse of x equals 7 to the x plus 2. Okay? Your homework is in Savas and should be listed as due tomorrow.
Sergeant.